electrostatic force in 2 dimensions. I'm going to put here F E L in 2D, and we will work with the problems that I have here. You can find this in a PDF handout on Canvas. This specific one here, this sample problem, is on page, I think the page is 638. It's like the second or third page in that PDF document that you have there. I'm going to do this one, and then I'm going to assign to you this one. So let's go ahead and do this sample problem 17b. I'm going to redraw this geometry because it doesn't look too great here. But what you have is 3 charges. You have minus, plus, and then you have, who knows what that thing is. I guess we'll see if we can deduce it. Oh, that's Q. Okay, Q1, Q2, Q3. That's Q3. Q3 is positive. That's plus. All right. Well, anyways, I'm going to redraw this so we have a nice big picture. And how do I want to do it? Let's just do it like this. Although, should I do the colors? All right. Anyways. Negative charge. This is, what am I looking for? I'm looking for a force on Q3. Okay, so this is Q2. Now the magnitude of Q2 is 2 nanocoulombs. It's -2, but I'm just going to put 2 nanocoulombs. Negatives implied in the picture. I have Q1 somewhere over here, so let's put plus here. This is Q1, and Q1 is 6 nanocoulombs. So I'm going to put here 6 nanocoulombs. Now I know this distance between these two. This is 3 meters. And then I have third charge, which is positive, and that's 5 nanocoulombs. So I have a positive charge here. Plus, that's 5 nanocoulombs. What I want is this. Okay, so Q3, 5 nanocoulombs. Now nano is 10 to the minus 9th. So I'm going to put this here. Nano, that's 10 to the minus 9th. Okay. This distance here is 4 meters. Since this is the right triangle, and I have 90 degrees here, this here would have to be 5 meters. We will also need the angles. So why don't we calculate this angle here? It's gonna come handy, so we need this one. You could either use sine, cosine, or tangent. Let me do tangent. So tangent of, let's call this thing theta. Tangent of theta, that's 3/4. Let's figure out what this is. Take the inverse of 3/4 and you get your answer. So, oh, I have to change from, well, that's true. You want to make sure that you're not in radians, but you're in a degree, because we want degrees. I mean, you could stick with radians, but let's go to, okay, I have to change this. Here we go. So 37 is what I have for the angle. 37 degrees. Theta here is 37. All right, so what I'm looking for is the force on Q3. What is the force on Q3? And it's pretty clear that there are 2 forces acting on Q3, and I'm going to have to add them up to get a net, the total force acting on it, on this particle. So the first force is the force of attraction between this charge and this charge, right? That's minus, that's plus. Oppositely charged particles will always attract. So what I have here is, maybe in blue, due to this charge, Q2, I have a force acting on this charge that points in this direction, and we're going to call this F2 because it is due to Q2. Now, due to Q1, I have a force acting on this in this direction, and this is F1 because it is due to Q1. Now, why does it point in this direction? Because the force between this particle and this particle is repulsive, right? This is plus, that's plus, and the positive particles will always repel, so it's a repulsive force, and therefore the force must act in this direction. So this is F1. Now I'm going to need this angle here but I know that this angle here is the same as this angle here, which I calculated before as 37 degrees. So I'm going to just put here 37 degrees. Okay. So I have F1 and I have 2. What I'm looking for is Fnet. Fnet on Q3, and that specifically would be F1 plus F2. But I'm in 2D, so I have to add these things as vectors. So I'm going to slide this picture, this whole thing now. And let's maybe first do F2 because it's less work. So F2, let's calculate that out. That would be Q times Q, because that's the equation here for force. So what I have here is Q2 times Q3. These are the two relevant charges, and divided by R squared. So this is 8.99 times 10 to the 9th times the two charges. So what I have is 2 and 5 nanocoulombs. So 2 times 10 to the negative 9th times 5 times 10 to the negative 9th, and then divided by the distance, which is 4 squared. All right, so this goes away, that goes away, and then the rest needs to be figured out. So I got 5.6 times 10 to the negative 9th newtons. That's F2, that's the magnitude of F2. Now if I want to put F2 into a vector form, that would be easy to do. Well, let's do it in blue. So F2 as a vector would then be, well, if you look at F2, it has no y component. It points along the x-axis, but in a negative direction, right? So what I have is minus 5.6 times 10 to the minus 9th, comma 0, has no y component, and it is only x component, but it is negative because this force points to the left. So this is F2. I have it in a vector form. Now let's figure out F1. So F1 equals, equation is K. Now the two relevant charges would be Q1 and Q3 divided by R squared. K is 8.99 times 10 to the negative, nope, not negative, times 10 to the 9th. So times 10 to the 9th, and then times the two charges, 6 and 5 nanocoulombs. So 6 and 5 nanocoulombs. 5 squared. So this and this goes away, and then I have to multiply out the rest. Actually, this and that goes away. So what I have here is 9 times 6 over 5. Well, I guess I'll put in 8.99 times 6 divided by 5. 10.8. So what I have here is 10.8 times 10 to the negative 9th newtons. So I have F1, and so what I still have to do is figure out the x and y components. So now if you look at F1 here, F1x points this way, and then F1y points this way. So F1 as the vector would then be, both are positive, right? This is a positive component, this is a positive component. They both point in positive directions. So I'd have plus, and then 10.8 times 10 to the negative 9th times, for the x component, it would be cosine of 37. For the y component, it would be sine of 37. So 10.8 times 10 to the negative 9th times the sine of 37. And that gives me F1 as, all right, so I have to actually calculate this. Let's see what we get. All right, so yeah, this times the cosine 37, we get 8.6 times 10 to the 9th, negative 9th. So this is 8.6 times 10 to the negative 9th, and then the y component goes with a sine is 4.5. That's wrong. I'm just reading it wrong off of my calculator. It's actually 6.5. So this is 6.5 times 10 to the negative 9th. Okay, so now I have F1 and I have F2. To find Fnet, you have to add them, and you have to add them vectorially. So Fnet is therefore, well, you take this component and you add it to this one, right? So what we have here is 10 to the negative 9th is the exponent that I have, so that stays the same. So effectively I have 8.6 minus 5.6. Well, that just gives me 3. So I have 3 times 10 to the negative 9th. And then the y component is simply 6.5 times 10 to the negative 9th, and the story ends. Well, almost. So this is fnet as a vector. And so plus plus, so that means that fnet points, you know, I have 3 to the right, 6.5, so maybe it points like this. All right, here's your fnet, it kind of points like that. The sum of the two forces would point more or less in this. Actually, I could figure this out if the way I drew it. So the way I drew it here is that the sum should point, I didn't really draw it properly, because according to the picture I have here, this fnet should point towards the left, so x component would be negative. I just drew it improperly. I should have this force should be drawn a lot longer, and this one should be drawn shorter, because what we have here is a plus. For the x component, we have plus for the y component. So my picture is misleading, but fnet comes out to be pointing somewhere like this. Right, somewhere like this, where there's a positive x component and there's a positive y component. Okay, so anyways, so we have fnet, but what we still have to figure out is, and of course that implies that this particle would accelerate in this direction here. All right, so we still have to find magnitude. To find magnitude of this force, we take the x component, square it, take the y component, square it, and then you get whatever you get. So this, I mean, we have to take the square root of this, and then you get the answer. For completeness, let's figure this out. So apparently it's 7.2 times 10 to the negative 9th newtons. Okay, so now we have it solved. It's done. So so I give you an example of how to do it, and what I want you to do now is two things. Well, first of all, I am going to assign to you this problem here, problem 2, and that's from page 639. So let me put this here as your homework. You have that on page 639, number 2. You may find it a little hard. We may have to go over that at home. Actually, let me just say, why don't you do just 2A? Just do 2A. And then when we come back and get together in class again on Friday, we'll look at 2B and 2C. So this way, you don't have to do the whole thing yourself. And if you get stuck on it, we'll go over that. We will go over these parts of it. But what you should also do is try to continue on with this problem. So we found fnet acting on this charge. But why don't you find fnet acting on Q1? So let me draw a picture for, let's see if I can find maybe different colors. So let's label, why don't we redraw? Okay, I know what I'm going to do. So this was red, this charge was red, because I used red for F1. Why don't we relabel Q3 in white? So here's Q3, and now what we can do is, if you want to find fnet on this charge, then what you have to do is determine all the forces. There are two. So between this particle and this particle, there's a force of attraction, and that force of attraction points in this direction. So call this F2 because it is due to Q2. But there's also a force of repulsion between this and that would be pointing in this direction. Call this F3 because it is due to Q3. And then you have to find fnet, net force acting on this particle. So I'm going to give you two things for the homework. Well, one is this, and then the other one is find, so let me label this as 1, and then 2, find fnet on Q1, where by Q1 I mean this. All right, so give it a shot, and then if you get stuck, submit whatever you can do as far forward, as much as you can do. Submit that. If you solve both of them, that's great. On next time we meet, we will finish problem 2, and I may go over this part as well, but I will definitely go over problem 2 in class. So don't bother doing 2B and C. Just do 2A, and we'll see how it goes. All right.